boys and girls, it's Miss Bassell. If you're absent from school today and took your test yesterday on topic 13, evaluating and writing numerical expressions, then it's time for us to go over, look at what you were doing correctly, and let's look at what you maybe need some help with. So you should have your math work notebook opened up to your topic 13 test. For the 15 problems, you should have your answers recorded as far as A, B, C, D answer choice, and you should be able to look back at your work. So we're going to look at number 1 first of all. Number 1 wants to know which equation has a value of 27. So this is an example of when we need to work the answer bank. And I actually am at home and I don't have my journal with me. So I am going to work on some paper right here. So I'm going to first of all work answer choice A. So in parentheses, we're looking at the product of 3 and 3 and adding 3 to it. So we have to use our rules for order of operations. That's that PEMDAS. And if you're using your graphic organizer, looks something like this, where we're going to work what's in parentheses first, and we only have one operation. So we evaluate the product of 3 and 3, that's 9, and we're going to bring down the plus and the 3 that we haven't used yet. And then we're going to add together, and we get 12. So we're going to go ahead and eliminate answer choice A. It has a value of 12. All right, we're going to look at B. So we're looking at the sum of 3 and 6, and we're multiplying it by 3. So again, with PEMDAS, we work what's in parentheses first, and since there's only one operation to evaluate, we just add 3 and 6 for 9, and 9 times 3 is what we do next. We haven't used the times or the 3 from the original expression, and we get 27. So it looks like our answer is going to be B. So, you know, your teacher, I like to just go ahead and make sure that it isn't C or D, and then I know for sure my answer is correct. So let's look at C. We're multiplying 9 times the sum of 6 and 3. So again, we start with those parentheses, one operation in it, that gives us 9. We bring down the 9 and the times symbol, and we get 81. So it's not C, that's good news. And then let's just check D. 9 times the difference of 3 and 3. My minus didn't show out too well on my printed copy. Now, you guys did this digitally, so you were able to see without any problems. All right, in parentheses, 3 minus 3 is 0, and bring down the 9 times, and we get 0 as the value. So we're absolutely correct. It was answer choice B. Let's look at number 2. What is the value of the following expression? So using PEMDAS, we work what's in parentheses first. Since there's only one operation, we go ahead and evaluate it. 14 minus 6 is 8. We take off the parentheses once we evaluate. We bring down the 4 and the times symbol because we haven't used those yet. And 4 times 8 is 32. So we look over in our answer bank, and there it is, answer choice B. All right, number 3 is very similar to number 1. That is where we have to find an expression that is equivalent to 5 times the sum of 4 and 9. So the first thing we need to do is we need to find out what this value is. Actually, no, I'm wrong. I'm looking at this. What I see going on is the distributive property. So let's talk about that. I don't have to work it out. One thing that I could do if I forgot about the distributive property, I could find the value of this. 4 plus 9 is 13, and 13 times 5, let's see, is 65. All right, so I could then work out each one of these to see which of these expressions is equivalent to 65. That is the longer way that you could solve it. Honestly, you're looking at the distributive property of multiplication over addition. So the way that works is since we're going to be multiplying the sum of 4 and 9 by 5, we can go ahead and distribute it, and we can multiply 5 times 4 and add it to the product of 5 times 9. So that would look like this, 5 times 4, and we would add it to 5 times 9. All right, so I'm looking over in my answer bank, 5 times 4 plus 5 times 9. Whoops, went off the paper there. Apologize for that. Looks like my answer is going to be A. And we already said our value of this expression was 65. If I want to check to see if it's right, I know 5 times 4 is 20. I know 5 times 9 is 45. And yes, it does equal 65. So, little ways that we can check our work if we really want to be conscientious and are going for that perfect score. All right, let's look at number 5. Number 5, which number is the value of this expression? So basically, we just need to solve it. So we're working with our order of operation rules. So we're talking about PEMDAS. So this is always something quick and easy that you can write out, the 4 levels. Anything in parentheses, we only have one operation, so we'll do that, evaluate 16 divided by 4 to get 4. We go ahead and bring down the 4 and the plus, and we go ahead and bring down the times and the 2. We only work one operation at a time. So next I'm looking, and I have addition and I have multiplication. So I'm coming down. I don't have anything left in parentheses. I don't have any exponents. I do have that multiplication. So I'm going to go ahead and put parentheses around just so that when I go back and look over my work, I see that that's what I'm doing next. 4 times 2 is 8. We bring down the 4 and the plus. That leaves addition last, and we get 12. So the answer to number 5 is C, 12. All right, number 6, we want to know which expression is equivalent to 6 times the difference of 8 minus 3. So I am looking at the answer bank, and this looks very similar to number 4, where we're really looking at the distributive property. Now, we could work this out. I know 8 minus 3 is 5, and 5 times 6 is 30, and I could work every single one of these problems and see which one has a value of 30, but that's too much work. What I notice is I could multiply the 6 times the 8, and then I could subtract the value of 6 and times 3. So I'm looking at 6 times 8 minus 6 times 3. All right. So I'm looking at did I put a minus there? My careless mistake. All right. So I'm looking for the product of 6 times 8 minus the product of 6 times 3. And I see that in answer choice C. No, I don't. Again, my bad. It's this one. Notice that Miss Basel almost went for the wrong answer, not looking carefully at the subtraction. All right, now the way we check it, we already said we know that this is going to be valued at 30. So 6 times 8 is 40. 8 minus 6 times 3 is 18. 48 minus 18 is 30. So that has the same value. So just a quick way to check it. All right, I want to know which expression is equivalent to 8 times the product of 7 and 2. So when I look at this problem, I'm looking to see which of the properties is being used, similar to what we just saw in problems, 4 and 6. I'm not using the distributive property here. What is happening is we are just going to be moving the parentheses. So the parentheses, we still have 3 factors, 8, 7, and 2. I'm pinpointing in on B. B also has 8, 7, and 2. And I am moving the parentheses. So instead of multiplying the 7 and the 2 first, I'm multiplying the 8 and the 7 first. But we can do that because of the commutative property of multiplication. So this one right here is one of our properties that we've been using, where we are changing not any of the symbols, not any of or operation symbols, and not any of the numbers. All we are doing is we are changing the groupings. So we're using the associative property of multiplication. All right, so that is answer B. All right, number 8. Which expression matches the words 8 less than the product of 12 and 4? I'm going to ignore the answer bank a minute. All right, so 8 less than means that I'm taking 8 away from something. All right, what am I taking it away from? I'm taking it away from the product of 12 and 4. And product means I'm going to be multiplying. So I'm multiplying 12 and 4. Now, because of the order of operations, I don't necessarily have to have parentheses around the 12 and the 4 because multiplication comes before subtraction, but I could have it there. Okay. The other thing that could happen is that I could, because of the commutative property of multiplication, I could have 4 times 12 minus 8, or in parentheses, 4 times 12 minus 8. So I'm going to take a look over here at my answer bank. The only one that has me subtracting 8 at the end would be answer choices C and D. And the only one that has the product of 12 and 4 is C. D is looking for the quotient of 12 and 4. So it's looking at 8 less than the quotient of 12 and 4. So I hope everybody sees why the answer is C. The product of 12 and 4 is in parentheses, and we have 8 less than the product of 12 and 4. All right, problem number 5. I'm sorry, what was that? 8. Problem number 9. How is the product of 12 and 10 divided by 5 written mathematically? All right, so again, just like number 8, we're putting an expression to some words. So I'm looking for the product of 12 and 10. Product means I'm multiplying, and then I'm dividing by 5. All right, so the product of 12 and 10 divided by 5. All right, it could be with or without parentheses. And because of the commutative property of multiplication, I could have 10 times 12. All right, but I see it right here. 12 times 10 divided by 5 is right here, answer choice A. All right, in a math quiz, Mr. Jostin reads out the following problem. Add 45 and 23, then multiply by 8. So we're adding, then we're multiplying. So that would be 45 plus 23, then multiply by 8. So what that tells me is I'm going to have to put this in parentheses, because if I do not have parentheses around the addition of 45 and 23, and if I just had it written like this, then because of the order of operations, I take care of any multiplication before I do addition. So I have to have the parentheses. So I'm looking for 45 and 23 added together and multiplied by 8, and I see it in answer choice B. All right, number 11. Thea has a toolbox with 4 shelves. Each shelf holds 11 tools. Thea gave her friend 3 tools. Write or which expression shows how many tools are left in the toolbox. So we have a toolbox with 4 shelves, and each shelf holds 11 tools. All right, so that would be 4 times 11 or 11 times 4. All right, to get the total number of tools on that shelf, on those 4 shelves. Then she gave away 3 tools. So we're going to subtract 3. So with order of operations, we could have the 11 times 4 to get the total number of tools in parentheses, or not. It doesn't matter, because in this case, multiplication is going to happen before the subtraction because of the order of operations. And we could have 4 times 11 minus 3. So let's see what we have over here. Sorry, these are minuses. They didn't show up on my home printer. So when I am working on this, I'm looking for 4 and 11 being multiplied together, and then 3 coming away from that product, and that is answer choice B. All right. Excuse me. Number 12. Miss Hull bought a box of 72 pencils and kept 30 of them for herself. She gave the rest to her 6 children so that each had the same number of pencils. Which expression could be used to find the number of pencils each child received? So let me put those minuses in. All right. So she had a box of 72 and she kept 30. So if she's keeping 30 of the 72, we want to subtract those out. So I think we'll all agree that when we take the 30 away from the 72, that will give us the number of pencils that she has left to distribute to those 6 children. If she wants the 6 children to have the same number of pencils, that's where you're dividing up those remaining pencils. So you're dividing them into 6 equal groups. All right. Yes, you do have to have the parentheses around 72 minus 30, because in order to figure out how many pencils she has left, which is going to be 42, we need to subtract before we then divide those those pencils into 6 different groups. All right. So I'm looking for the difference of 72 and 30 divided by 6, and I see it. Answer choice B, 72 minus 30 divided by 6. All right, we're moving right along. We're looking at problem number 13. Ayana's sticker album contains 9 pages. Each page has 24 stickers. Ayana removed 7 stickers. Which expression shows how many stickers are in her album? So let's go back through this. So her album has 9 pages, and each page has 24 stickers. So to figure out how many stickers are in that album, we're going to multiply 9 times 24. We have 9 groups of 24. All right. And then from that total, or from that product, we're going to subtract the 7 to represent her removing 7 stickers. So I'm looking for, and it could be without parentheses because multiplication does come before subtraction when we follow the order of operations. It could be 24 times 9 minus 7. But I see it very clearly. Answer choice D. We're multiplying 9 pages times the 24 stickers on each page, and we're subtracting out the 7. All right, number 14. Brenda currently has 11 butterflies in her collection. She collects 3 more butterflies each day for 7 days. Which expression represents the total number of butterflies Brenda will have in her collection? So she has 11 in her collection. All right. She collects 3 more butterflies each day for 7 days. So she has 11. So she's adding to the 11 that she has 3 more butterflies each day for 7 days. So in that 3 or 7 groups of 3, so we could do 3 times 7, or we could do 7 times 3. All right. Now, couple things here. We could or we could not have the parentheses, all right? But we do have to have 3 times 7 plus 11. Now, the only place I see a 3 and a 7 being multiplied together and 11 being added to it is D. So it doesn't matter that the adding 11 comes at the back of our expression, because in both these expressions, wouldn't we multiply 3 times 7 first? And then we would add the 11 because addition comes after multiplication. So our answer is D, written this way. All right, number 15. Allison took 3 trips to the Everglades and saw 14 alligators each time. She also saw 5 lizards on her last trip. Which expression can be used to find the total number of alligators and lizards that she saw on her 3 trips? So basically, we want to find out how many animals did she see in total. So she took 3 trips, and each time she saw 14 alligators. So that would be 3 groups of 14. Okay. So she only saw those 5 lizards on her last visit. So once we obtain the total number of alligators she saw, we can subtract from it those 5 lizards. Okay. Now, I'm looking over in my answer bank and I see it. Let's see. I see it. Oh, sorry. I'm adding 5, not taking away the 5 alligators. I was wondering why my answer wasn't, well, it was, my incorrect answer was D, but let's go back. We were looking for the total number of animals that she saw. So I have to add the 5 lizards that she saw to the total number of alligators. So that would be answer choice A. All right, so just, you see me sometimes get ready to pick the wrong answer, but what I always do is look back over the question and read it one more time to make sure my answer makes sense. And that's how good mathematicians can catch themselves from picking a wrong answer carelessly. All right, so boys and girls, we've talked about these problems for topic 13. So when we come back to class, when you get back to class, we're going to move on into our next unit of study, which is going to be topic 11, volume concepts. All right, I hope you have a great day.